Hello, everyone. Now let us continue our data wrangling, and then we are looking at handling missing and then the missed data. This time we are looking at method 2 of how to handle the missing data. Okay, so as usual, what we are going to do is you can go into the code file and then just copy. You can copy the entire code and then you can practice along, okay? All right. So we are looking at, this time we are looking at the method 2, which we will be looking at the data imputation, okay? You are imputing missing data. So in other words, you are looking at replacing the missing data rather than deleting the missing data as a whole. Because there's, in some cases, you might have a lot of missing data, and deleting the missing data can actually reduce the data drastically. So you wouldn't want to do that, but instead you would actually want to impute the data set by replacing it with some values that are very close to what is originally in the data set, okay? All right. So in this case, let us look at it. So again, first of all, in the code, you have to set your working directory to where the data set is. The data set we are actually going to use here is what is called the iris. We are looking at the iris data, which I intentionally created it so it has some missing values within this particular data, okay? So let's set the working directory, and then now we are actually going to import the iris data. We import it, let us run the summary. Okay, so we can just put the cursor there and then run the summary. So there's the summary. You can see that the separ length, the separ weight, the petal length, they have what missing values or missing information. So with that, let us look at one of the first methods in which we can actually impute the data set. One of the methods is to actually replace the data with either the mean or the median. So in other words, all the missing values in the data set, you might want to replace it with the mean, okay? Now, if you have continuous, data set, and the data set, you know that the data set is pretty normal, then it's good to, you can use the mean to replace the missing values. But if the data is skewed, then it is advisable to use the median, because the median tend to be more robust when it comes to skewed data. Okay, and also in some cases, if you are that's if you are dealing with a continuous data set. But if you are dealing with a nominal or categorical data set, then you can actually use the median as a mean of imputing and replacing the missing values. Okay. Okay, so now what we are going to do is we are going to go into our iris data, and we are going to, from using this $sign, we are calling the separ length, okay? And then what we are saying is we want within the separ length to identify all the missing data. So we are using the is.na function, and then also again go into the iris data and then pull out the separ length. So what we are telling iris now in the separ length data, get us all the missing data of that separ length. And now what we are actually going to do is we are going to be able to replace it with what the mean. So we are replacing all the missing data with the mean of the separ length. So again, there's the iris data. With this $sign, we are able to pull out the separ length. Okay. Yeah. And then we are telling R that the NA is equals to a true, which means there is NA within the data set. And that's how you can actually compute a mean when you still have NA by introducing NA.rm to be equals to true. Okay. So in this case, we can go ahead and then run our code. So once we have run our code, let us see whether we still have NAs in the separ length. So we can just go straight away and then do the summary, okay? Summary of iris. data, and then let's run it. Okay, so now you can see that initially we have 13 missing values in the sepal, but now the missing values have all been replaced by the mean. So now we don't have missing values anymore. And you can, over here, you can see that the mean is still retained the same mean, which is 5.288, and over here 5.288, 828, sorry. Now, another method is what we call the multiple imputation. So the multiple imputation is actually a very flexible and robust method for handling missing data. So rather than actually, unlike the mean in which you are actually replacing in a single value, the multiple imputation actually allow you to be able to replace it multiple times to get a more robust replacement for the missing data, okay? So it works especially when you are doing modeling, okay? Which is very important, which actually in the data set, you can actually, it can iterate it several times and then generate a complete data set for you to use. So before you use the multiple imputation, there is a package you have to install, which is called the MICE package. So once you have installed the MICE package, you have to activate it or load it. So I have already installed it, so I just have to load it. Once you have done that, we are now coming to name our new data set, which is the imputed data set. We are going to name it as what? As imputed iris data, okay? So now we are going to make use of what is called the MICE function, okay? And then we are now going to call our data set, okay? So we are going to call our data set, and then we have in the MICE function, we have other argument, which is M, and then method, okay? M is specifying the number of times you actually want to impute. That is M. So you are only specifying the number of times you want to impute. And by so doing, you actually allow the algorithm to replace the missing data in several separate times, okay? So in this case, M equals 5 means that we are going to impute the data. The data will be imputed 5 times, okay? In 5 separate times, and eventually the best one will be taken for replacing the missing data. And then with the method PMM, the PMM represent the predictive mean matching, okay? So this predictive mean matching is also very beneficial in terms of it's appropriate for a particular effective way when you are actually looking into continuous data set. It actually helps you to preserve the original data distribution. That's if you are using the PMM method. There are other methods that are used, but the best method I recommend is the PMM method, okay? So now we can go ahead and then run this. So now after running this, we can now look at use what is called the complete function to be able to ensure that we obtain our imputed data, okay? So we name new underscore iris, which is the data which is going to have the imputed data. Then we are going to use the complete function which we have imputed iris data, which is this particular data we imputed, and then we have 1. Now that allows us to be able to obtain the imputed data, okay? So we can run it. So now we have run it. If you want to see the entire data, you can actually look at it over here. So you can go through it and then you can see there is no missing data. But either way, you can actually use you can use the summary to see. So you can see that now if you look at the summary, there is no missing data in the summary. Whereas if you look at the summary of the iris data itself, look at we have NAs for sepal width and sepal length, right? But then once we actually apply the multiple imputation, if you use the summary, we can see that we don't have any missing data anymore, right? And then you can look at the dimension. The dimension is now 150 by what? 150, that the number of row is 150, and then we have the number of column to be 5, right? Then also there's also another thing you can actually do here is to actually plot the distribution of observed and then imputed values, okay, which is a plot you can actually use to observe. In this case, we can have the imputed data, and then we'll be looking at observing the cell power length and then cell power width, okay? So you can actually go ahead and run this line of code just to see the plot, okay? So there's actually the plot, which is actually giving us the plot of the imputed data, distribution of the imputed data for iris and then cell power length and cell power width, okay? Now, one also simple way in which you can actually compete certain, you can do some calculation even with the data still having some missing information. And that is by using the NA.R to be able to ignore all the NAs and then compute the do the calculation in which you're actually looking for, compute the function. So for instance, if you want to find the sum of the cell power length, okay, in the iris data, you can just say that sum of the cell power length. So, and then we use the N.rm equal true, which means there is NA. So the NA is going to be ignored, and then we can actually get our sum. The same thing for the mean. We can get mean of the cell power length by introducing the NA. We can just calculate our mean for the cell power length. And then we can also calculate our standard deviation for the cell power length, again, using the NA equal true for you to ignore any missing data. Okay, so here is it. So, okay, so now you have this also under your belt where you have two approaches in method one. If you have already watched that video, we actually look at how you can completely replace, delete or exclude all the missing values from the data for analysis. But this case, the method two, which is this presentation, we actually look at, rather than completely deleting the missing values, we are actually replacing the missing values. And we have it in two ways, by looking at the mean and median replacement of the missing values, which is called the mean median imputation, and then also looking at the multiple imputation, where it's actually it is more robust way to replace your missing value. Okay, so I will see you in the next lecture.